In lesson 3.9, you are going to be modeling decimals with base 10 blocks. So you will need to get your Ziploc bag of those blocks and work along with the video and the cubes and the longs. Before we begin that though, we'll do a math warm-up using your whiteboard marker, and of course you'll need your eraser. These are just great ways to review some of the skills that we have already worked on so you don't forget. On your whiteboard, you're going to number 1, number 2, and number 3. If at the top you would like to just write our number 341,811 and just put a box around it, that will help you with rounding. So we're going to round this number 3 different times. For the first one, we'll round it to the nearest 100,000. For the second one, we'll round to the nearest 10,000. And for number 3, we'll round to the nearest 1,000. Would you go ahead, pause the video, and round this number 341,811 to the nearest 100,000, 10,000, and 1,000. Go ahead and pause the video and complete it. For number 1, rounding to the nearest 100,000, we're going to circle the number in the 100,000s. 1 to the right, 5 or more, raise the score. 4 or less, let it rest. It's 4 or less, so we let it rest, and everything after the 100,000s turns to a 0. Next one, nearest 10,000, so that's in blue. Look to the neighbor, 5 or more, raise the score. 4 or less, let it rest. And it's 4 or less, so we're going to let it rest. And everything after the blue 10,000s place turns to a 0. To the nearest 1,000, the 1 is in the thousands. Look 1 to the right. 5 or more, raise the score. 4 or less, let it rest. And it's 5 or more, so we're going to raise the score from a 1 to a 2. And everything after the thousands place turns to 0. Go ahead and erase. And I would like you to go ahead and number 1, 2, 3, and 4. We're going to think in terms of money for a few minutes. For number 1, how many dimes are in a dollar? So if I had a dollar bill and I wanted to collect coins, which there happens to be a shortage of right now, how many dimes would I get for that dollar? What fraction of a dollar is just 1 dime? Then I have a question about how many pennies. How many pennies are in a dollar? And what fraction of a dollar is 1 penny? Would you please write the answer to these 4 questions? Go ahead and pause the video. Number 1, how many dimes are in a dollar? There are 10 of them. What fraction of a dollar is 1 dime? Well, it's 10 hundredths or 1/10. Remember how we talked about equivalent fractions? 10 cents would be the same as 1/10 or 10 hundredths. Same thing. How many pennies are in a dollar? 100. What fraction of a dollar is 1 penny? It's 1/100th of a dollar. So today we're going to be talking about tenths and hundredths with decimals and fractions. What I would like for you to do is use your large sheet of paper that has 100 little boxes that looks just like this. You're actually going to put that sheet beside your iPad along with your base 10 blocks. What I would like for you to do is take 1/100th or 1 cube, and on your sheet of paper of your 100 grid, go ahead and put 1 cube in there. We could write that as 1/100th Or we could say it covers 1 out of the 100 boxes. Both of these are equivalent. Now what I'm going to ask you to do is I'm going to give you several different ways to fill your 100 grid. And then what I would like for you to do is to be able to write it as a fraction and as a decimal. So I'm going to ask you to take 6 longs and 2 cubes. Would you go ahead and place that on your 100 grid next to your iPad using your Base-10 blocks? Please fill in 6 longs and 2 cubes. You will have to pause this video as you work today. Now I had to color mine in, but you would have 6 longs and 2 cubes. So this is how much of your 100 grid would be covered with your Base-10 blocks. Now what I would like you to do is on your whiteboard, I would like you to write that as a fraction and as a decimal. So let's start as a fraction. So on your whiteboard, you have, this is 10, 20, 30, 40, 50, 62 out of the 100 boxes that are covered. 62 out of 100 or 62 hundredths. As a decimal, would you please write this on your whiteboard? 62 hundredths. That's how we'd write it as a decimal. Now I'm going to go ahead and erase this because you're going to use the same 100 grid and I'm going to ask you a different combination. So I would like you to put 4 longs on your 100 grid. Go ahead and do that. Pause the video. So if you put 4 longs on there, how many longs would it take to cover the entire 100 grid? Well, it would take 10 longs, so that becomes our denominator. So on your whiteboard, would you please write a denominator of 10? The bottom number tells me how many it would take to cover the whole square. How many of them now are covered? We have 4 out of 10. Write that on your whiteboard. Now we're going to write an equivalent decimal for that. We don't have a full square covered, so we put a 0 in the ones place. And the first place after decimal is called the tenths, which means it takes 10 of those to cover the whole thing. So 4 tenths and 4 out of 10 is the same amount. All right, go ahead and move those 4 longs. I'm going to erase mine. So I'm going to give you another one. I want you to take 6 cubes. Just 6 cubes and cover your 100 grid with 6 cubes. Stop your video. Now, my question is this. My denominator becomes how many cubes does it take to cover this whole area? It would take 100. And how many do I actually have sitting on that 100 grid? I have 6. Please write that on your whiteboard. Now what we'll do is we'll write an equivalent decimal. I don't have a full grid. The first one refers to how many longs or tenths it takes. The next place value after that is the cube. So this refers to if we use longs or tenths, 10 of them to cover, or cubes, which would be hundredths, because it would take 100 of them. We don't have any longs, but we have 6 cubes. That would be read as 6 hundredths. Go ahead and move your cubes. Now what I would like you to do is take 1 long and 7 cubes and place them on your 100 grid. Remember to pause the video as needed when you are placing your longs and your cubes. When placing 1 long and 7 cubes, I want you to write a fraction for what part of your 100 grid is covered. Well, first of all, write the denominator. How many cubes are needed or how many squares would need to be filled to cover this entire thing? 100, that becomes our denominator. And how many of those small cubes are covered? 10 for the long, and 7 for the cubes, so 17 hundredths. On your whiteboard, write 17 hundredths. Now we're going to go ahead and write a decimal that is equivalent. Remember, this is the ones. This refers to the longs, or what we call the tenths place. And the second one is for the cubes, or what we call the hundredths, because it takes 100 of them to cover the whole grid. So we have 1 long and 7 cubes. We have 17 if we were to cut them all apart, 17 hundredths. All right, now we're going to put our cubes away, and we're going to go ahead and work in our math journal. So you might want to pause the video while you are putting your cubes back in and your longs back into your Ziploc bag. We're going to move to journal page 91. We're going to move away from using the cubes and the longs to just shading in. On page 91, we have tenths and hundredths. Tenths refers to longs. Hundredths refers to cubes. It says at the top, write the fraction and equivalent decimal for each grid. Well, the fraction, let's go ahead and count how many are covered in number 1. 1, 2, 3, 4, 5, 6, 7, 8. 8 cubes out of the 100 that are needed. As a decimal, remember, this stands for longs. These are the cubes. And the more official word that we use is tenths, as it takes 10 longs to cover it, and cubes, which are hundredths, because it takes 100 of those to make a full 100 grid. Notice that both of these have the THS, and this stands for a whole grid being covered. So as a decimal, in the tenths place, we don't have any longs, but we have 8 cubes, and that would be read 8 hundredths. Number 2, we're going to count. I'm going to count how many longs, so 1, 2, 3, 4. If I count down 1, 2, 3, 4, 5, 6, 7 longs and 2 cubes. So each one of those longs is 10, so that would be 70, 71, 72. 72 out of the 100 that I need to cover the whole grid. How would I write that as a decimal? Well, let's look back to this shortcut to help us understand. We have 0 whole 100 grids filled. We have 7 longs and 2 cubes. In other words, if we were to cut them all out into individual cubes, it'd be 72 hundredths. 72 hundredths. Number 3, we have 10, 20, 30, 40, 50 individual cubes, or 5 longs. So as a fraction, we have 50 hundredths. We also could say that's 5 longs out of the 10 that I need to cover the entire amount. Or I could even say half of it's covered. As a decimal, we're going to go ahead and say we have 0 entire flats, or the 100 grid. We have 5 longs. We also could call that 50 cubes. Either way, we can call it 5 tenths or 50 hundredths. Moving on to the middle of page 91. It says color part of each grid to show the decimal given. Remember, the first place after the decimal is called tenths, and that's the same thing as a long. The next place is called the hundredths, and that refers to the cubes. So if you look, we have what's called 9 tenths, 9 longs. So Go ahead and shade in 9 longs. It's a lot of shading. Remember, you can pause this video at any time. The next one is read 9/100ths. Say it with me. 9/100ths. If we look, there's no longs, but we have 9 cubes. So shade in 9 cubes. 1, 2, 3, 4, 5. 9 cubes. Number 6. We read this as 46/100ths. Say it with me. 46/100ths. We have 4 longs and 6 cubes. So 4 longs. 1. Go ahead and shade this in your math journal with me. And then 6 cubes. And we say 46/100ths. What you're going to do on your own on number 7, 8, and 9, it says color part of each grid and write the decimal represented. So you get to decide. You're only going to, let's say, a shade in 1. The decimal, again, remember, this refers to the whole grid, what we call the ones place. And this refers to longs, or what we call the tenths place. And this refers to cubes, what we call the hundredths place. So if I were going to just shade 1, my decimal would be 0 longs and 1 cube. Would you do that for those 3? For this lesson 3-9.